Lab number 11, back or indirect titration. We have two kinds of titration. Direct titration, as we studied before, and today we are going to deal by back titration. For the direct titration, if I want to describe this process, it is fast process, complete, ends with product, accurate, so we can calculate the number of moles and molarity, and the analyte used in the direct titration must be soluble, pure, and non-volatile. For the back titration, which we are going to study today, it is described as slow process, it needs heat, the analyte that is used in the back titration would be insoluble, impure, volatile, or it is the reaction of weak acid plus weak base. Our example today for the back titration experiment is calcium carbonate. As we know, calcium carbonate is insoluble and impure substance, so we can't analyze the amount of calcium carbonate in our sample by using direct titration, so we are going to make back titration with HCl. The molar ratio from the balance equation is 1 to 2. We will add a total amount of HCl on the calcium carbonate, and the result will be calcium chloride, H2O, CO2, and the remaining unreactive HCl, which we call it HCl excess. To calculate the amount of HCl excess, we have another direct titration with NaOH to obtain NaCl plus H2O and end our reaction. So, to make a back titration, we have two equations. The first equation, which represents the back titration reaction, it is accomplished by the total amount of the analyte, for the titrant, and the second equation is a direct titration with a strong base or strong acid. After that, we calculate the purity of our analyte by calculating the practical weight over the actual weight multiplied by 100%. To calculate the practical weight, we need the number of moles of our analyte multiplied by its molecular weight. To calculate the number of moles of calcium carbonate in our example, the number of moles of calcium carbonate equal the number of moles of HCl total minus the number of mole of HCl excess divided by 2, because in the chemical equation the molar ratio between calcium carbonate and HCl is 1 to 2. We are going to weigh 0.3 gram of our analyte, calcium carbonate. We'll transfer our sample of calcium carbonate into Erlenmeyer flask. We add to our purette 0.1 molar HCl, so it is our titrant. We will add 50 ml of HCl on our sample. we will wrap our flask with paraffin and put our sample in the water bath and wait for 10 minutes. After that, we cool down our sample. After cooling down our sample, we will add 3 drops of phenolphthalein indicator and titrate the HCl excess which is present in our sample with NaOH. So we add 50 ml of NaOH 0.1 molar in the puree. This is our endpoint, and it consumes 4 ml of 0.1 molar NaOH. For the analyte, the mass of our analyte is 0.3 gram and the molecular weight is 100 gram per mole. For HCl total, the molarity is 0.1 and the volume used 50 ml. So, the number of moles of HCl total equal molarity multiplied by volume in liter. 0.1 multiplied by 0.05 equal 0.005 mole. For the NaOH, the molarity is 0.1 and the volume is 4 ml. Number of moles of NaOH equal the number of moles of HCl excess. Molarity multiplied by volume in liter equal 0.0004 mole. So, we can calculate the number of moles of calcium carbonate, which equals the number of moles of HCl total minus the number of moles of HCl excess divided by 2, and it is equal 0.0023 mole. To calculate the practical weight, which equals the number of moles of calcium carbonate multiplied by its molecular weight, which equals 0.23 gram. And finally, we can calculate the purity percentage of calcium carbonate, which equals the practical weight over the actual weight multiplied by 100%, 0.23 over 0.3 multiplied by 100% equal 76.7%, which means that not the total 0.3 gram, which equals the 100% is calcium carbonate. 76.7 of this weight equals calcium carbonate, and the remaining weight is impurities.